No, that's not the URL address.
Hello, my name is Jerome, and this is my project on an ionic and covalent bond.
Okay, well, how you want?
Now, for my ionic bond, strontium and nitrogen is in my ionic bond. An ionic bond is a bond where atoms gain or lose electrons.
That's just
Crystal, now you about to...
I got you.
Okay. Ionic bond. A bond is where atoms gain or lose electrons, or electrons are transferred. Step 1. Sr is strontium. Strontium has an atomic number of 38. It is an element on the periodic table. It is a metal. Step 2. Group 2A is where strontium lies. Group 2A elements have a charge of +2. Strontium, step 3, has 2 valence electrons. Step 4, it will lose 2 electrons. In other words, its protons will be 2 more than its electrons, which explains why group 2A elements have a charge of +2. Now, strontium has 36 electrons and 38 protons, but why is that? The reason is strontium wants to have a noble gas structure, step 5, like krypton. Krypton is stable with 8 valence electrons in its highest energy level. So now it has 36 electrons, just like krypton. Step 6. Strontium forms an Sr+2 ion. This is also known as a positive strontium ion or a strontium cation. Strontium ion. Sr+2. You can also call this a metal cation because strontium is a metal and this is a cation because it is a positive ion. Now,
You send it?
I'm doing it now.
let's move over to nitrogen. Step 1. N is for nitrogen, the symbol for nitrogen. The atomic number is 7. Nitrogen is a non-metal. Step 2. Nitrogen is in group 5A with a charge of -3. Group 5A elements have a charge of -3. Step 3. Nitrogen has 5 valence electrons. Step 4. It will gain 3 electrons. Now nitrogen has 10 electrons and 7 protons. That's why the charge is negative, because the electrons outweigh the protons by 3. Why is that? Why does nitrogen do this? Nitrogen wants to have a noble gas structure like neon, step 5. Neon is stable with 8 valence electrons in its highest energy level. Step 6, it forms an N-3 ion. This is also known as a negative nitrogen ion or a nitrogen anion or a non-metal anion because nitrogen is a non-metal and it's also an anion because it's a negative ion. Now, the ionic bond formula is as follows. The ionic bond formula is a 5-step way in order to create an ionic bond. Research, I came across this. It's a simple 5-step way to come up with an ionic bond. And I cited my sources, yahoo.com and honorspellstartlogic.com. Step 1 of the ionic bond formula. Step 1, write the symbols for the metal and the non-metal. Step 2, write the valences or the oxidation number as superscripts above each symbol. Superscripts lie in the top corner of the element. Instead of at the bottom, which is a subscript, it's a superscript because it's at the top. Super, top, sub, bottom. Step 3, drop the positive and the negative sign. Step 4, crisscross the valences so they become a subscript for the other element. So you would take wherever the superscript lies and just put it in the subscript's place of the opposite element. Step 5, reduce subscripts whenever possible. In order for you to reduce a subscript, the number must be able to be divided by, well, yes, the number must be divisible by a number greater than itself and 1. That is very important. Now, here is the ionic formula for strontium and nitrogen. First, I will show you the final steps, the 5 steps, the 5-step way to figure out the ionic bond. Then I'll show you the final outcome. Ionic bond formula. Step 1, write the symbol, SR(N), strontium, nitrogen. Step 2, SR plus 2, N minus 3, positive, negative. Positive ion, negative ion. Step 3, write the superscripts. SR2 and 3. Here it seems as if they're both positive. SR2 and 3. Steps. These are the valences, I'm sorry. Crisscross the superscripts. N3 will move over here by strontium. They'll become SR3. N2. 2 from strontium will come over here at the bottom of N and become N2. SR3 and N2. You cannot be reduced because there isn't a number that you can divide these by a number greater than itself in 1. 2 and 1, that's all you have for 2. For 3, all you have is 3 and 1. The final outcome is strontium nitride, SR3 and 2. This is the ionic bond between strontium and nitrogen. Strontium nitride. Strontium nitride is our final outcome. Now, let's look at the Lewis structure and the Bohr diagram for strontium and nitrogen. Thank you so much, Crystal, for your help. You're doing wonderful. Zoom in on the bottom, please. Thank you so much. Strontium. Its Lewis structure before it loses the electrons is as follows. 2 dots for its 2 valence electrons. Strontium is in group 2A once again. Now, after it loses 2 electrons, it now becomes positive with 36 electrons, like krypton, and it is also stable. You cannot give people the wrong information. After it loses 2 electrons, it is now positive because it has 38 protons and 36 electrons. Its protons outweigh the electrons by 2. It has 36 electrons, just like krypton, and it's stable because now we can have 8 electrons in its outermost energy level. Now, SR has 8 valence electrons and is positive, plus 2. Thank you. SR plus 2 with 8 valence electrons. Now, let's move on to the Bohr diagram. Energy level 1, 2 electrons, 8 electrons, energy level 2. Energy level 3, 18 electrons, full. 8 electrons, energy level 4. And in 5, its highest energy level, 2 valence electrons, because it is a group 2A element. And before its longhand electron configuration was 1s2, 2s2, 2p to the 6th, 3s2, 3p to the 6th, 3d to the 10th, 4s2, 4p to the 6th, and 5s2. But after it loses 2 electrons, this is its new Bohr diagram. 2 electrons, 8 electrons, 18 electrons, and in its last energy level, which is now 4, 8 electrons, just like krypton. It has 36 electrons like krypton and is stable. 8 electrons in its outermost energy level. Now, moving on to nitrogen. I know, Crystal, hang in there. Before, its Lewis dot structure has only 5 dots because nitrogen is a group 5A element. After it gains 3 electrons, its new Lewis structure has 8 electrons, or 8 dots now, because it gained 3 electrons. See? 1, 2, and 3. Now, its original Bohr diagram was 2 electrons in its first energy level and 5 electrons in its second energy level. Its long-hand electron configuration before it gained 3 electrons was 1s2 and 2p to the 5th. After it gains 3 electrons, it now has a full outer shell or 8 valence electrons in its higher energy level, just like neon. It has 10 electrons, and here are the 3 that it gained. Now nitrogen has 10 electrons like neon and is stable. Now here's a little something extra. The valence, as we were introduced in our ionic bond formula, the 5-step format, the valence or oxidation number of an element is the charge of an element when it gains or loses electrons. For example, Sr plus 2 or N minus 3. Those will be their valences. After it gains and loses electrons, nitrogen becomes N minus 3. When strontium lost its electrons, it became Sr plus 2. So plus 2 and negative 3 were strontium and nitrogen's valences or oxidation numbers. That's ionic bond.